Hello Pre-Calc, I hope you all are well. Our objective today is going to be to plot coordinate points and convert to and from polar and rectangular form. I've got the checklist on the screen. Please double check and then hit continue when you're ready to go on. Okay, so we are going to switch things up on you all today. We are going to start plotting in a totally new graphing system. So in the years past, you've been plotting what's called rectangular coordinates. So like x comma y, right? One of the reasons it's called rectangular coordinates is because like when you look at that graphing paper, it is literally rectangles, right? So your first number tells you how much and in which direction to move horizontally, and the second number tells you your vertical movement, right? Now we're going to convert into looking at polar coordinates, and that's going to mean we have totally different graphing paper. So let's take a look at what this means. All right, so your graphing paper is now going to look circular as opposed to like a grid of squares or rectangles. And hopefully you got a little bit of practice with this on the Desmos activity, and you hopefully also have some access to polar graphing paper from your teacher. Typically, each circle is going to represent a radius of 1. So like this first circle has a radius of 1, the second one has a radius of 2, and so on and so forth. The particular grid, if you will, that I'm using here is going in radians, each by pi over 12, right? So you've got like pi over 12, pi over 6, pi over 4, etc., and going all the way around to 2 pi. So instead of x comma y, we now have r comma theta, and so that first number is r, that's literally like what circle you're on, your radius, right? And then your second number is your angle, typically in radians, okay? So if I want to plot the polar coordinate 3 comma pi over 6, I'm going to go to pi over 6 first, which is going to be here, and I'm going to go to the third circle, so 1, 2, 3, it would land right here, right? And you did a little bit of this on Desmos already, you just didn't really know what you were doing. Now, one thing we didn't look at on that Desmos activity is what if my radius is negative, right? We talked about negative angles, but we've not yet talked about negative radius. Now, if you've got a negative angle, one way to find that is to take your positive angle and flip it over what? Flip it over the x-axis, right? Now, if you've got a negative radius, what I recommend is first plotting just positive 3 comma pi over 6 back here, okay? Now, a negative radius is going to flip over the origin, also known as your pole. We'll talk about that in just a moment. So if I take this green dot and now flip it over the origin, I'm going to shoot it across the origin here. I'm going to land right about there. So you can see here, basically it's a 180-degree rotation, right, or 1 pi radian. All right, so one thing we want to do, now that we've got kind of two ways to plot points, is be able to convert from one to the other. So let's explore a bit. If I want to graph the point 3, 4 in rectangular coordinates, which is what you've been doing for years and years now, I'd go to the right 3, up 4, right? Now, let's talk about where would that point land. It should land around the same place on the polar plane, okay? So first up, some notation here. The origin is called the pole, okay? And what was known as the x-axis is now known as the polar axis, okay? So first, we need to figure out basically what circle are we on, right? And that is your radius. And now your radius is your distance, right, from the point to the origin or the pole. So how could I find this distance? We've been doing this for a long time, right? I could find r by using good old Pythagorean. So square root of 3 squared plus 4 squared, which is going to be square root of 25 or 5. Okay, so there's my r. Now theta is going to be this angle made by the positive x-axis and this line that I drew here, right? This dotted line. So again, we've done this. We did this with parametric recently, with vectors, that theta, one way to find it is going to be to say, well, inverse tangent of y over x, right? So inverse tan of 4 over 3. And if we want to use a calculator in degrees, this is going to be about 53 degrees, okay? So I'm going to go to the fifth circle, 1, 2, 3, 4, 5. I'm just going to eyeball this 53 degrees a little bit more than halfway, so somewhere here. And if you will notice, okay, our points do match, right? They're in quadrant 1, same distance from the origin, making that same angle. All right, I'm going to force a pause on your screen. Can you please write in your notes converting from a rectangular to a polar coordinate? Okay, so if I want to go from rectangular, that means I'm given xy, but I want to convert to polar, r theta. Well, think about that example we did, or that exploration we did. To get r, we took the square root of x squared plus y squared, right? Just your distance formula, basically Pythagorean theorem there, okay? Now, theta, the way we found that was inverse tan of y over x. Now, if you are given points that correlate to unit circle angles, use that. But if you are using a graphing calculator or calculator of some kind to determine this theta value, be really careful, because remember that your calculator does not know what quadrant you're in. So I'm going to put plus A. I'm going to do a little asterisk here. Remember that you're going to have to adjust, okay? So if I'm in quadrant 1, we're good. In quadrant 2, you need to add 180 degrees, also known as pi if you're in radians. Same in quadrant 3, and remember in quadrant 4, to adjust you need to add 360 degrees, which would be 2 pi in radians. So this is if you're using a calculator, you are going to have to adjust based on what quadrant you're in, because your calculator does not know what quadrant. It's going to assume an acute angle. Okay, so example 2, convert the rectangular coordinate -3, 2 to its polar coordinate r, theta. All right, so let's find r. My formula is square root of x squared plus y squared. My x is -3, so squared is +9, plus my y is 2, so squared is 4. So I'm getting square root of 13 for my radius, okay? Now theta is going to be inverse tan of y over x, right? So 2 over -3. Now let's think about what quadrant that point lies. So what quadrant are we in here? We are in quadrant 2, right? So we need to add what in radians? We need to add pi to adjust. So let me type this in. So I'm going to go inverse tangent of 2 over -3, close parentheses, and then I'm going to go ahead and add pi right away. And again, this is in radians, so about 2.5, 2.55, 3 if you truncate, 2.554 if you round, radians. Okay, so I'm going to go. So my final answer, r, theta, is square root of 13, 2.554. And remember, that's in radians, and 1 pi, radian, is 180 degrees, so we are in quadrant 2, most definitely, not yet past 1 pi. All right, so what if I want to go the other way around? Well, let's come back to this kind of exploration page. Notice that I've made a triangle here. Notice that cosine of theta is going to be what? It will be x over r. In other words, if I were to solve for x, I would need to multiply both sides by r, so I'd get that x equals r cosine theta, right? And if I were to do the same thing for sine, I would get that y equals r sine of theta. And that right there tells you exactly how we're going to convert from polar to rectangular. I'm going to force pause on your screen. Go ahead and write this title here. All right, so if I want to go from polar, so that would be r theta, to rectangular, that would be x, y. We're going to do exactly what we just saw. So x is going to be r times cosine of theta, and y is going to be r times sine of theta. All right, so let's try example 3. Will you write 2, pi in your notes? While you write that, I'm going to go ahead and plot that point. So second circle at pi radians, and we're just going to follow our formula. So x equals r, which is 2, cosine of theta, which is pi. Now, if you can, please use your unit circle, okay? So if we give you an angle that's on the unit circle, use your unit circle so that you're getting an exact answer. So what is cosine of pi if you think about your unit circle? That is -1. So 2 times -1 is -2. Let's do the same thing for y. I've got y equals 2 sine of theta, which is pi. And what is sine of pi? Sine of pi is 0. So for y, I'm getting 2 times 0, which is 0. So my rectangular coordinate is -2, 0. Well, if we were to plot that point on a rectangular grid, it would land exactly where the green dot is, right? It would go to the left 2 and not up or down at all. So here's the thing that is unique about polar points as opposed to rectangular, is that you have multiple representations of the same point, right? So if you were given r theta, there are tons, an infinite number actually, of other points that are going to land in the same spot, okay? So one way would be to keep your radius the same, but what would you need to add in radians to theta to get back to where you were? You would want to add 2 pi, right? A full rotation, 360 degrees would get you back to where your original theta was in terms of location. And subtracting, by the way, would get you there as well, right? So would you write that, please? That one way is to hold r the same, but add or subtract multiples of 2 pi, really, okay? Now our other option is to make r negative, or change the sign of r. Now when I change the sign of r, what do I reflect about? I shoot it across the origin. Remember that from the very first example. So now, how many radians would I need to add to theta to get back to where I initially was? I would need to add half a rotation, right? Which would be just pi radians, or 180 degrees. And of course, subtracting, that will work as well, okay? So please make sure you've got this written down. There are 2 ways we could find another representation. One is to keep r the same and to add or subtract multiples of 2 pi, a full rotation. Another way is to change the sign of r, so make it negative, and then add or subtract just half a rotation to get back to where you were. All right, force a pause on your screen. Can you please copy example 4, and then we will do it together. All right, so example 4 says plot the point 3 comma pi over 3 and find 3 additional polar representations for theta in this interval -2 pi to pi. Okay, so let's start by plotting that point first. I'm going to go to pi over 3 on the third circle, so I should land about there. Okay, now we want to find 3 more representations, and according to that previous screen, one way is to keep r the same. So I'm going to hold r, and then I could add or subtract how much to my theta. I could add or subtract multiples of 2 pi. Now, if I add 2 pi, I'm going to be in trouble because I'm going to be over 2 pi, and it said to stick between -2 pi and 2 pi. So what I'm going to do is I'm going to subtract 2 pi, which as a denominator of 3 would be 6 pi over 3, right? So my r is still 3. 1 pi over 3 minus 6 pi over 3 will be -5 pi over 3, right? Let's check this point and make sure we did okay. So if I plot, oh dear, if I plot just +3 comma +5 pi over 3, I'm going to be on the third circle here, right? Now that negative angle, that negative theta, I flip across what? The x-axis. So I was here, flipped across the x, I would land right there where the red dot was, so we are good there, okay? So far we have done step 1, basically, from that first line, that first green line. I can't do any more of those because it's going to take me out of that interval from -2 pi to +2 pi. So let's go with strategy number 2, this one right here. So let's change the sign of r and then just add or subtract 1 pi. Okay, so let's do change r to be -r. So -3. Now for my angle, since I've already reflected that point across the origin, I'm just going to want to add or subtract half a rotation. So I'm going to add how much? Just pi, right? Also known as 3 pi over 3 if I want a common denominator here. So I have negative 3 comma 4 pi over 3. And let's go ahead and check that representation as well. So again, I like to plot, just take off all the negatives, plot positive 3 comma positive 4 pi over 3. So that is going to be 1, 2, 3 right here. Now that negative on R shoots it across the origin, so yes, I do land back there where I want to be, okay? All right, last one. We want one more. So this time, again, I'm going to make R negative. For theta, I'm now going to subtract half a rotation. So subtract how much? Subtract pi. So I'm going to subtract 3 pi over 3. So I've got negative 3 comma negative 2 pi over 3. So now I've got a negative both in R and theta. So keep in mind, how does a negative R reflect? Shoots across what? The origin. And how does a negative angle reflect? Over the x-axis. So I'm going to go first to just positive 3, positive 2 pi over 3. All right, so that would be here. Now if I reflect across the origin first, it doesn't matter what order you do this reflection, by the way, I'd be here and then reflect across the x-axis. Yes, I'd be here right where we want to be. All right, I'm going to force a pause on your screen. Can you please copy example 5 as well as make a table with 2 rows and 7 columns for me? All right, so it says complete the following for R equals 8 sine of theta. So we want to make a table with these theta values. So I'm going to go ahead and put theta up here and R here. And go ahead and fill in this first row with your theta values for me. So pi over 4, pi over 2, etc. All right, now we're just going to put these points into the equation they gave us up here. So I'm going to start with the sine of pi over 4. Sine of pi over 4, think about your unit circle is what? Is root 2 over 2. Now when I multiply that by 8, I'm going to get 4 root 2, right? Okay, so go ahead and fill out the rest of the table and then hit continue when you're ready to see the answers. All right, here's what I've got so you can check your answers, erase anything or change anything you need to. And now what we're going to do is match this to the correct graph. We're going to be doing more graphing very soon. Right now we just want to get you comfortable finding these values of R and theta. So here are, let me move myself. Here are your options to choose from, okay? What I would recommend is looking at where you have some nice values. Particularly, I find it easiest to look at your quadrantal angles, meaning 0, pi over 2, pi, 3 pi over 2, 2 pi, especially where you don't have a 0 for your R, okay? So what I mean is, what I would really zone in on, I'm sorry, very hard to circle with this tablet. I would zone in on this value here, okay? So I want to be on the 8th circle at pi over 2. Well, look at your options. There is only one that satisfies that criterion. Which one do we have? Let's call it A, B, C, or D. That would be this one, B, right? Because here I am on the 8th circle at an angle of pi over 2, and that's the only one that goes through that point. So that's the one you want to choose. All right, you all, that is it for today. We will see you next time.